All right, so I think we're gonna go ahead and get started. Just want to let you know that this workshop will be recorded. So if for some reason you're unable to attend or remain in a recorded session like this, you will need to drop. We will make the recording available after sometime today, later today or tomorrow. So you have the ability to follow the workshop and follow the presentation as well on the recorded webinar. But if you're able to join us, welcome and thanks again for joining us. So today we're going to talk about Azure Synapse Analytics and Analytics in a Day, which will walk you through mainly Synapse, but as well all the different services that involve Synapse. I'm going to introduce myself real quick. My name is Jose Chinchilla. I'm the Director of Data Analytics for Agile Thought. And you can see some of the books and materials that I've written and some of the certifications I have. And I've been working with Synapse for a little bit over a year now since its inception. And I'm excited that you join us today to learn a little bit more how Synapse can be a good fit in your organization and what the Synapse service provides. Just a plug here for some of our recorded events that we have available on our website. Please feel free to check our Accelerate Summit recordings. We have very good conversations with panelists, especially the one that I facilitated around the three must knows when implementing artificial intelligence. We had great set of panelists from representing different industries. So I hope you can watch those, as well as other recorded and on-demand webinars that we have available through our website. And please feel free to check those out. I am sure you're going to find those useful. So today, like I mentioned, we're going to talk about Azure Synapse and how it integrates with Power BI. How do you do all the ingestion and the data modeling with Power BI, and also the in the ingestion ETL that you can do within Synapse using the data integration features. And we're going to do a quick introduction on why we're talking about Azure Synapse and why we need to break through some of those silos and how Azure Synapse helps with that. And then just understand kind of the background or the history about data analytics, what has been the new paradigm shift around data analytics. And then we're going to do a hands-on lab that I'm going to guide you through, so you can experience Synapse and all the different features that it brings together. So first up, let's talk about the state of analytics today. Microsoft has made a statement that they believe that all businesses are data businesses, right? And ourselves here at Agile Thought, we believe that it's true, right? That is the driving force for any business. Data could mean many different things to different organizations, but at the core, data is what drives pretty much every business and every organization. So one of the things that we need to level set is what can analytics do for a business, right? How can the cloud enable better insights? And what is the inherent tension in the traditional approach to data analytics? And what would be that ideal end state for analytics? So we will, I will talk through some of these topics throughout the rest of the presentation, and then show you how a service like Azure Synapse helps with this new way of thinking about data analytics. So definitely data analytics now is at the heart of every modern business, right? So regardless of what industry or vertical your business is in, data is at the core. Over the last several years, we have seen that digital transformation is happening across many different industries and many different regions in the world, many different organizations. In 2020, we've seen these digitally transformed organizations having to quickly, rapidly adapt to sudden disruptions due to COVID-19, the pandemic. They've had to essentially change all their business processes around and do everything remote and everything in a digital format. So that same element that lies at the heart of digital transformation is also the underpinning of organizations that have proven most resilient during this turbulent time, right? And that underpinning pretty much is data. Data is what enables both the analytical power, the ability to analyze the past, be able to gain new insights, and the predictive power, right, that analytics offers. And be able to essentially predict the future and be able to plan ahead, right? Be able to look ahead and be able to adapt proactively to changes in the workplace, changes in the marketplace. From the, and this applies everywhere from the corner store with just their, perhaps their online accounting, QuickBooks, etc. Their stock keeping, inventory systems to the largest internet resellers. Every organization pretty much runs on data now. Those organizations that are able to manage, govern, secure data effectively will be the organizations, businesses that will thrive in this new economy, right? And that's the whole reason why we are here, being able to thrive in this changing marketplace. Now, of course, it's one thing to be able to gather and manage all this data, but there's a whole different conversation about how to make decisions based on data. And this is where analytics comes in, typically in the form of dashboards and reports that support the awareness of the current state of the business. Also, with business intelligence and visualizations that strengthen the role of knowledge workers, right? Those data analysts, those frontline managers, frontline workers, with more informed insights about what's happening, right? And then with other emerging technologies like augmented intelligence that can discover information and patterns that even the most seasoned, most experienced analysts, managers, frontline workers may often overlook, because there's so much data, so many things that only perhaps a machine could bring forward, right, in a efficient manner. Now, while data analytics is important, it is increasingly evident that not all analytic efforts are equal. Data science, for example, takes the traditional data analytics to a whole different level because it enables more automated insights with a depth and scale beyond the abilities of humans, right? It's not feasible anymore for human beings to analyze and be able to run queries through millions, potentially billions of records, and be able to take fast decisions based on all of that information. The data volume is just too much, and to make things even more complex, right? It's not just the volume of the data; it's also the different types of data and the different systems that are now involved in everyday business. So using machine learning and artificial intelligence, for example, can drive more autonomous processes and decisions, and organizations can respond more intelligently, but also more efficiently and faster, right? But in order to fully achieve that automation and depth of what analytics, data science can provide, businesses need to scale the solutions that they make available to their knowledge workers, their data analyst managers, so that the organization is not in the business of managing servers, right? It's not in the business of managing data centers. It's not in the business of keeping the lights on so that their knowledge workers can get to the data, right? The organizations now want to focus on just focusing on their core business and making sure that data is available, but they don't want to be essentially stuck in a data center, right? They don't want to have a 100 people, 100-person team just managing servers, right? That's not what businesses want to be in right now. Now businesses just want to see IT as a service that enables those insights so that they can focus on growing the business, right? So that's where the cloud really shines, and it has been a transformative process to a lot of organizations. And specifically today, we're going to be talking about Azure Cloud, Microsoft's cloud platform. Because the cloud enables companies to be able to start and scale projects easier and faster than they could even think of, using an on-premises approach, on-premises solution, right? A lot of projects that we've seen, that we've worked with some of their clients, have not been able to get started because they have to go through this hardware acquisition. They need to go through this infrastructure assessment, infrastructure estimation, right? How many servers, how much horsepower, how much storage, who's going to install it, who's going to maintain it. So there's a lot of overhead around starting new business initiatives with an on-premises approach. That's why the cloud has now become the default environment for new technology initiatives. And we've seen this across all of our clients, where now the mindset is, hey, a new solution, a new business initiative. The first thing is, okay, let's start this in the cloud, because the cloud will allow you to start at a very low barrier of entry without minimal or no capital expenditures, right? No procurement process that takes months or maybe years. It lets your business initiatives essentially start quick. So that ongoing shift to cloud native applications, including all the collaboration, file sharing platforms, really puts more data within the reach for analytics, right? Instead of focusing on managing databases and figuring out how you're going to extract that data, the cloud allows you to just connect to those sources and start your analytics journey, right? The benefits offered by the cloud, as well as its proven security, reliability, has led to a mass migration, right? Even organizations that in the past have been bound by governance, compliance, obstacles or challenges, are now taking either a hybrid approach or full-on cloud native, right? In terms of their solutions, because cloud platforms like Azure already have done their compliance, auditing, security checks, and have obtained certifications across, healthcare for HIPAA compliance, financial, PCI, credit card compliance, personal PAI compliance, as well as some other regulatory requirements like SOC and ISO. And GPDR for European privacy, right? So all of this is already built in the cloud. You don't need to spend months, if not years, coming up with a compliance and governance plan, because a lot of this is already built in with Azure. So that's one of the major advantages that organizations are able to take advantage of immediately. Now, cloud-based analytics platforms eliminate the need for large capital CapEx investment, like I mentioned, right? Deploying to the cloud is faster, it's easier, and it's more flexible than a traditional on-premises data solution without that high hardware infrastructure costs. It also allows you to iterate on different architectures, different designs, and be able to handle more diverse data than much more efficient than it was in an on-premises solution, right? So we're talking, flat files, text files, CSV files, JSON, XML files, as well as, of course, relational database sources, web API, and other web related sources. And of course, the cloud makes the world-class performance and that elastic scaling available to all users. And that is a very important point that I want to make. Sometimes when we engage with some customers that have some type of data analytics initiative, the conversation always goes around how much horsepower, how much hardware do we need, right? And we can only estimate how much data volume in the next year, 2 years, 3 years, and trying to look into the future and give them a good estimate on how much storage, how much horsepower they need. But those are just estimates, right? And in some cases, guesstimates, because it is hard to predict, that in 2 years there's going to be, a twice or triple the growth in the data volume, right? Because organizations can be acquired, they can acquire other businesses. So it's hard to predict a lot of these things because there's so much variability in the marketplace, right, in business. But we provide as best as we can a good estimate, and we expect for those estimates to be accurate, given the criteria that we get. But there's also those unpredictable factors, right? Not just changes in the marketplace, but hey, if you have a good product, good business that is really taking off, how fast can organizations adapt and be able to procure the infrastructure to support that growth, right? There's many use cases, many customer success stories around that, where the cloud has enabled them to scale up to support all that demand in their web traffic, in their e-commerce, for example. But the most important thing that a lot of organizations miss is not the ability to grow in scale as fast as possible to support that demand, but then it's also the ability to scale down when that demand, levels off. And that is an important lesson learned for a lot of organizations, a lot of customers that we have talked to, because they had all these, estimates that, hey, in 3 years, we're going to have 10 times as much business, and we need to procure all this hardware infrastructure. And then in 3 years, 5 years, they find out that, that estimate of growth was way too optimistic. And now they have servers and hard disks just spinning there, spending, power, requiring a dedicated IT team to look after them. And, they're just under utilizing all that infrastructure. So with the cloud, it enables you to scale when you need it, scale up, but also scale down and be able to meet the demand more closely, as opposed to just having servers sitting there, right? That in 3 years, 5 years need to be replaced. So that is an important lesson learned for a lot of our customers, where they have seen those benefits of elastic scaling up and down from the cloud. By the way, if you have any questions, anything that you want to ask, feel free to post them in the Q&A section. You should see a little icon at the top to write down your questions. And throughout the presentation, when we take a break, I will take time to answer those, either verbally or I will try to answer those on the chat as well. So as the volume of variety of the data continually expands, right? Modern cloud-based data services serve as the home for all of this data. Workloads, of all different types, from enterprise data models to small BI sandboxes to predictive analytics. All of that can be stored and managed and provisioned together. Or at least that is what the recommendation best practices is, right? You don't want to have all these disparate systems where you have to move data around with all these different technologies, these different teams with total different skills, different tooling, because it just creates a lot of complexity, right? The cloud enables you to more efficiently handle all these different types of data, all these different use cases of the data, all of these different schedules, processing schedules, like ETLs, self-service analytics, without the need to someone juggle all these different and complex systems and try to integrate them all together, right? It allows that consolidation in standardization of your data repositories and your tooling. And it allows you to deliver those enterprise-wide data sets, data marts, reports, and also fosters innovation because now you are able to securely and in a scalable manner allow your business users to access the data to do some type of data discovery, ad hoc, and get some ad hoc data insight, right? With either visualization tools like Power BI or more specialized data science, machine learning, AI tools and platforms, right? All within that cloud, private cloud within Azure. Now, you may have already started your journey, your data analytics journey, and you might be at a different maturity stage than some other organizations, but one of the things that is common across all organizations and across all different stages of your maturity, the data analytics maturity, is that you have a ton of choices, right? You have pretty much endless capabilities for analytics in the cloud, and you have a lot of vendors, specialized third-party tools and platforms. And this might be overwhelming for those of you who need to make a decision on which platform, which service, what third-party tools should you use. And all these choices and options sometimes overwhelming, and you're not alone. Even us in the consulting world, right? It's sometimes hard to choose the right platform, right service, because all of them have great features, great capabilities. And sometimes customers feel overwhelmed by all these choices, and you're not alone, and you're not wrong thinking that this is a hard decision to make, right? It is a very strategic decision to put a architecture and a plan that will get you to your business goals, right? And that's where consulting companies like us help, because we've seen what works across many different industries, across many different organizations, and we have that up-to-date knowledge of what are the latest features, latest efficiencies that you gain from a lot of these services and platforms. But with all these different choices and some of these complexities of mixing multiple tools and platforms, even in the cloud, has gotten us to a point of what I will say is like a paradox, a paradigm shift, or a paradox, right? And the reason is, we have an ever-growing volume of data. The industry analytics expect that data will quadruple, or now I think the latest update is more than quadruple, right? Between 2020 and 2025, we're collecting data at a much higher rate than before. And based on some surveys they have done, like Gartner, Forrester Research, they have discovered that about less than 30% of the data is actually analyzed. About 30% of that data has been exposed to decision makers and knowledge workers, business analysts, data analysts, managers that has been available to them because of the sheer volume of the data and lack of tools, the right tooling to be able to get to this insight. So the problem is not as much that that 70% that get analyzed. That it doesn't mean that it's not useful. It doesn't mean that doesn't have any impact in the business or that there's no understanding of that data. Because of the volume of data and the complexity of these data solutions, it's simply being put off, right? Simply ignored. Other data sets, other areas of the business have been prioritized, and this other data sets or these other data has just been pretty much shunted off, right? Not even considered as part of the core analytics capabilities. So one of the conversations that Microsoft and some of these research companies have had with like Fortune 1000 leaders, they have expressed that, although data analytics and AI are at the top of their investment, data initiatives in these areas can be prohibitively challenging because, they struggle to advance their data insights. About 80% responded that they just struggle to advance, right, those initiatives. More than half blame the issue to data silos and the management of the tools, services that has created roadblocks, right, in this endeavor. And more than half also admit that they don't really treat business as an asset, not because they don't think it's valuable, because it matters. They just don't have the processing capability to get there, right? They don't have the platform, they don't have even the budget to bring all of these different tooling together. So that has been a challenge, right? The silos, the management of the solution, and just the sheer volume of the data and budget constraints. So, but part of this issue that a lot of these Fortune 1000 leaders has expressed is not that it has to do with the technology itself, their processes, their skills, but it's really how the industry as a whole has approached analytics up to now. So for many decades, organizations have adopted specialized technologies, specialized patterns and architectures, for example, like data warehouses, data lakes, to handle very specific types of data, and that has helped organizations collect, analyze data of all sizes and formats. But these are so specialized and so specific for some use cases that it has created like niches of data, niches of technology, niches of skills, and essentially, has created what we refer today as data silos, skill silos, technology silos. So this has led to the ultimate paradox of analytics, right? The more we apply new technologies, a new approach to analyzing data, the more silos we create, right? So it's a compounding effect where you introduce new technologies, you introduce new ways of integrating analyzing data. That by itself is creating silos, not only with the data itself, but also with the skills and the tooling required for that approach. So to be able to move forward, to be able to harness the power of data, we definitely need to break down these silos without creating new ones and have a holistic approach to data analytics. So, furthermore, not only the integration and availability of data, but has created these silos, but also the way organizations have to resort to visualize, report, to govern the data and in recent years to create some data science, machine learning, AI type of programs. So each new technology they adopt, they create new siloed operations. The task of connecting all these different systems requires, like I mentioned, specialized skill sets, specialized tooling, specialized protocols, processes, and in most cases, even duplication of data, right? Which essentially creates silos. Now, when you step back and consider the traditional approach to data analytics, building a new system for each new activity, new initiative, each new solution, maybe made sense at the time because that was the fastest way to get there. However, as the volume of the data and the complexity of these different systems continue to increase, adding more and more technologies only compounds the problem again, right? So it's not feasible. It's not a long-term solution. So there comes a point in which that complexity of adding more technology and more, creating more of these silos outweighs the benefits of that technology, that solution itself, right? So a more holistic approach is the key to unlocking this paradox, because the goal of modern organizations is to simplify and make data accessible across all their entire organization, right? There's all this conversation about the democratization of data and also the simplification of processes. And that is the ultimate analytics continuum, right? That modern organizations have decided to take on. So today, it's common for decision makers to increasingly reach beyond, traditional reports and dashboards to engage with new sources of data and new sources and new tools available, including some of the big data, machine learning, and AI approach and capabilities. However, the more advanced the technology, the more siloed the data and skill sets are required. And it becomes harder to even understand the implications, short and long-term implications, by trying to adopt all these different capabilities without a clear path forward. So that's why Microsoft took a new approach to analytics in Azure to enable this holistic experience of business insights in analytics. Microsoft did a lot of investment re-architecting the operational and analytics data stores to take advantage of new cloud-native architectures. This fundamental shift allowed Microsoft customers, Azure customers, to maintain consistent tools and languages, and has enabled long-held data silos, tool silos, skill silos to be eliminated. And now decision makers from across organizations are better able to access and understand the insights they need now that those silos have been removed. There's some great examples that I'll talk about. Some of the customers that have been able to successfully adopt Azure Synapse Analytics and remove some of these silos. So at the core of all these new continuum of analytics and breaking of these silos is the new offering from Microsoft Azure called Azure Synapse Analytics. And you can define Azure Synapse Analytics as a limitless analytics service that brings together data integration, enterprise data warehousing, big data analytics, and reporting into a single service offering with pretty much unlimited scalability and faster time to insights. With Azure Synapse, organizations can run the full gamut of analytics projects and put data to work much quicker, more efficiently, and much more secure. And because it combines all these capabilities, right? All these data engineering, data modeling, machine learning, visual insights in a single place, in a single experience, without having to create new silos, new processes, new copies of the data. You will see when we get to the hands-on lab how all of these capabilities come together in that same user experience that we're going to talk about in a little bit. Now, there has been some customers already that have adopted Azure Synapse Analytics, like Walgreens, Mintra, Procter & Gamble, that have achieved tremendous success with Azure Synapse. And now that Azure Synapse is now more global, generally available globally, now you can also get access to these capabilities, right? Just by deploying Azure Synapse within your Azure subscription. So up to now, we have talked about the value of analytics, the challenges of data analytics, the role that the cloud is now playing with modern analytics, and the paradox that many of us have been facing with your environments when you try to do analytics, and what that ideal state should be for that more of a fluid continuum of data analytics. Now we're going to go a little bit, dive a little bit deeper into Azure Synapse to describe a little bit of how it works and give you some tips on how to optimize your analytics, and then have a hands-on experience of Azure Synapse toward the end. So Azure Synapse, like I mentioned, it provides a consolidated, unified experience that brings data ingestion, big data analytics, data warehousing, reporting together at a cloud scale and with security on top of mind. So instead of having to stitch together all these different services, platforms, even within Azure, right? If you in the past have had to spin up an Azure Sql database, a HD Insight, Spark cluster, Azure Databricks, Azure Data Factory, Data Lake, bringing all of these, connecting all of these different services together has been a little bit daunting to a lot of Azure customers, right? And particularly to some of our customers as well. They really want to provide all these capabilities, but they want to do it securely, and they want to be able to manage it, much better, right? Without having to go through all these configurations and ARM template deployments, and they want a more unified approach. And that is the answer, right, that Microsoft has come up with Azure Synapse, as it unifies data, all the data tasks, and the different data teams as well, with a really limitless analytics service that pretty much does it all, right? From ability to run SQL queries, or ability to ingest data, ability to model data, and ability to run Python, PySpark notebooks, all within a single place, right? Single service. And it really simplifies all those monotonous, but often necessary data chores that every team must do, such as developing data pipelines, securing those pipelines, assigning user permissions, user access, putting firewalls in place, and so on, right? It's really a lot of overhead just to be able to provide that access, the capability to your business users. So with Azure Synapse, all you do is secure one place, right? And that's called what's called the Synapse Studio, one place within the Azure Synapse service that takes care of pretty much everything. The Azure team behind the scenes, they have automated a lot of these configurations, all the security for you, so that you can deploy Azure Synapse, and specifically Azure Synapse Studio, and all of that is built in for you. All that security, all those configurations, firewalls are built in. So, all these Fortune 1000 leaders that we talked about, what they have been asking all this time is simplified data analytics. And that's what, in my opinion, the Azure team, the Azure Synapse team, in this case, has delivered, right? So I'm very excited that you're here and that you are learning about Azure Synapse, because you will learn how easy it is to deploy, how easy it is to start working with data right away. So creating an analytics service that unifies all these siloed, divided worlds really redefines what the capabilities of analytics service must provide. And that is the effort that Microsoft and the Azure Synapse team has been involved in for several years, right? This is not something that came up in a year or two. It's been an evolution of understanding those needs and putting together this multi-year project that resulted in Azure Synapse Analytics. And then pretty much Microsoft set out to re-architect and create this new next wave of query processing capabilities for some of these new modern workloads. And one of the enhancements, or one of the innovations that came out of this multi-year project with Azure Synapse is a new cloud-native distributed SQL engine that has deep integrations with not only with the traditional SQL Server engine, relational engine, but also with some of these big data platforms like Spark, that allows a whole new level of collaboration, productivity among data professionals that before wasn't that easy, right? It wasn't easily available. So now, given this huge range of functionality available with Azure Synapse, it's really nice to have a choice on how you allocate and consume resources as well. So today, Azure Synapse offers two modalities of allocating resources. One of them is a serverless model, and then the other one is a dedicated resource model. And that gives you more flexibility and better control over your budget. If you already have a good estimation on how your SLAs, what the performance and scalability is required, and you want more predictable cost, more predictable not only cost but a predictable performance as well, you can create dedicated resources like dedicated SQL pools to reserve that processing power that you require. Now, if your workloads are a little bit more unplanned or have spikes or very, a lot of seasonality to it, then you can always make use of the serverless endpoints, meaning the resources are there available. They scale down, and sometimes you can set them to shut down and only come up online or scale up when the workload is there as needed. Right? So there's these two modalities, and there's a lot of documentation on the benefits and when you would go for a serverless resource model or a dedicated resource model. So next, we're going to talk a little bit more about some of the different features that Azure Synapse provides now, and how all of those come together holistically in a more optimized analytics approach. Then we're also going to talk about the integration, data ingestion, data integration capabilities, the data warehousing capabilities, and of course we're going to talk about how this integrates with Power BI, which is one of the preferred reporting, visualization, dashboarding tool that is available from Microsoft and the leader in the marketplace. So with that said, we're going to take a quick 5-minute break. Let's do some stretching, get some water, get some coffee, something to eat really quick if you want to. And then we're going to come back and talk a little bit more about those Synapse features. So with that, I'll talk to you in about 5 minutes. All right, so we are back. Hopefully you're able to join again. So, so we're going to continue, and we're going to talk about some of these features, some of these attributes, capabilities that Azure Synapse has introduced. One of them is around security and compliance, right? How can we have a centralized, unified governance and controls within a Synapse environment? So when it comes to data protection, Azure, has built in data protection into the fabric of the service, right? It is a secured mentality. It's a security first, right? This is not an afterthought. This is really has been built in into the service from the beginning. With Synapse, you get a very comprehensive approach to security, from access and authentication to proactive threat protection and compliance. And because it's built within Azure, that means that you don't need to maintain, patch this service. It gets the latest updates and features as they roll out. In the screen, you can see the list of all the different security, compliance, and capabilities. And like I mentioned, from data protection, encryption, either at rest, in transit, all the access controls using role, R-O-L-E, role level security, as well as role level security, being able to secure down to the row, right, data rows. To the authentication, all right, including MFA or multi-factor authentication, leveraging Azure Active Directory, and securing data at the source, right? For example, with SQL Server, Azure SQL Database, you can use, SQL logins, you can use managed identities, service principals, etc. And then in terms of networking, right, all the security around making sure that there's no breach in the data, and this might be in the form of just putting firewalls and network security groups within your networks or virtual networks, VNets. Establishing dedicated connectivity, like with ExpressRoute, VPN, and or also limiting the traffic between these different services with Azure Private Endpoints and Azure Private Links, right? If you haven't read about that, very cool security feature that allows all services to communicate within your VNet. Data traffic doesn't go to the internet or to the Azure backbone. It's all within your subnets, your VNets, right? And then some advanced threat detection, threat protection. Microsoft, as you may be aware, they fund a lot of research into analyzing threats. So they proactively block, certain IPs. They block certain type of traffic. They have dedicated teams just monitoring and putting this threat protection in place for you. So, like I mentioned, when the Azure Service Analytics service is deployed, one of the things that happens for you behind the scenes is it creates, deploys, and manages a virtual network that allows connectivity to your data pools seamlessly and securely, right? Allows you to be compliant. This way, your team doesn't have to do all of these setup configurations, maintenance. All of this is taken care for you, and there's a lot of documentation around how it is deployed and how this is secured as well. In addition to that, Microsoft has made available data governance policies that you can very easily apply through the native integration with Azure Purview. So If you're not familiar with Azure Purview, that's a new service that allows you to discover, classify data assets based on the policies and procedures that you have put in place, and provides you with that end-to-end data lineage, right? So really allows you to understand your data, the sensitivity of some of these data elements, and how does that data move along through the different your different processes, different analytic processes, right? So one of the use cases that I mentioned I was going to talk about is it's a customer called Grab, which recently I think they went publicly traded. And how Grab used Azure Synapse to help ensure that it was meeting local data security and sovereignty requirements across all the countries that they had customers throughout. And I believe this is about 8 countries. Yeah, 8 countries that they were operating on. And they were able to use Azure Synapse to achieve the data governance and compliance requirements without a heavy lifting and without third-party specialized tools. All of this within the Azure Synapse service. So it's a great customer success story that I would encourage you to read. Microsoft has a nice article, nice documentation on this success story. Now, integrating data is probably the biggest problem when it comes to modern analytics, right? I'm sure that you have dedicated developers, dedicated teams, just ingesting that data, processing that data, and then integrating that data together in some sort of data warehouse, some sort of data lake. And as the data moves in those data pipelines, it often creates a lot of different copies of the data, a lot of different shapes and aggregations of the data, and creates a lot of duplication of data. If there's an error along the way, you have to go back, redo a lot of this, and it just creates an unmanageable situation. And often, some of these data formats, data shape, data outputs typically create silos, right? Because they are like created for a specific use case, like a data mart for a division, a business team. And then if another business team requires a different format, different shape, then you create another extract. So all this becomes different silos that are just hard to connect, hard to manage, and hard to govern sometimes, right? Most of the time. So Azure Synapse employs a hybrid approach to data integration, and essentially puts everything that you need at your fingertips to bring all of these different data sources, data formats together. And not just the ability to consolidate, unify your data sets, data sources, but also be able to accommodate for the different skills and preferences in terms of programming languages, coding approach, using either a low-code, no-code interface, or creating a more script-based interface, SQL-based interface, and for some of those big data, more modern workloads, including machine learning, AI, even a Python interface, or even a C# interface, as you will see, you'll find out, during our lab. And all of this, not just the ability to integrate, consolidate, unify data and tooling, but also unify all the different executions, schedules, triggers to keep your data current, right? If you are familiar with Excel, specifically with Excel Power Query, which is the window that opens when you go to data and do some data manipulations. Also, if you're familiarized with Power BI, you are aware that Power BI also includes the Power Query transform data section. that allows you to take advantage of this low code or no code data shaping, data transformation interface. So now Power Query, which is in Excel, which is in Power BI, is also now available in Azure Synapse. So you can create Power Query or M-script based pipelines right there within Synapse with little or no coding experience. So this is a great story for those business analysts, data analysts that are used to Excel or are used to Power BI, and they want to also leverage those Power Query pipelines or Power Query data transformations in Azure Synapse. It's all the same interface, same window, same experience. Now, with all these different sources coming together, you might think that latency, creates a challenge, right? We want to make sure that we process the data as quickly as it arrives, and the data is made available to the users as fast as possible. So with Azure Synapse, you have the ability to integrate, ingest, process data in real-time fashion, right? More of a real-time analytics. There's a section that we're going to talk about real-time operation analytics, but I just want to emphasize that Azure Synapse makes all this real-time possible with latencies less than the 92nd at the 99th percentile, and really expedites time to data. So in addition to that, there's also a feature that allows you to build traditional data warehousing, right? Dimensional models, DIM, fact tables, and as well as data lakes. And if you have these workloads, these data warehousing workloads, currently, using SQL Server, Azure SQL Database, you can very easily migrate this over and support that same SQL workload, SQL development interface and experience and capabilities, right? All within Azure Synapse. And and if you have not, or you have already embarked in your data warehouse journey, you may have experienced that it has taken months, if not years, to get this data warehouse up and running and just running right? With the right dimensional models, the right granularity, the right relationships within all your tables, and be able to capture those business processes correctly in those fact tables. So the payback period for some of these data warehouse initiatives has been very, very slow. It has taken years, and even we have encountered customers that they're well beyond a decade in their data warehousing journey, and they still don't get it, have not gotten it right. They're still working through a lot of challenges there. Mainly, some of these challenges has to do with scalability, right? And with Azure Synapse, it allows you to fully manage this elastic platform and pretty much provide a ready-to-use solution for any size or level of the business. It gives you all these features in a single tier and provides that elastic computing capabilities to be optimized for the different use cases, different workloads, and allows you, of course, to have better control of your budget, of your costs. One of the controls that Azure Synapse provide is in that unified workspace is the data preparation, data management, data warehousing, big data, machine learning, AI in one location. This is a very highly visual, code-free interface that works for pretty much every developer experience, developer audience, and at all different levels of skills and experience. developers like, data engineers, data architects, they can manage all the data pipelines. Your database administrators can automate all the query optimization, table design, indexing to support these workloads. And data scientists can build proof of concepts in their data, in their AI, ML models within minutes, right? They don't have to wait for data to be available for them. It's right there, and they can just plug or create a notebook and start running code from the same experience. And this experience is what Microsoft calls the Synapse Studio. And the Synapse Studio is a web-native development experience that ties everything together in one location. So the data engineers, database administrators, data scientists can do their tasks without having to create all of these different integrations and maintain all these different tools, everything in the same development experience. So anyone can use it. It's very easy to manage. But the question is, does it really deliver on the level of performance for your business needs? And the short answer is yes, right? Why am I confident about saying that it does deliver on these promises? That is because Azure Synapse teams make sure that they created benchmarks and tested this against other platforms. And an organization called GigaOM created these benchmarks or run these benchmarks using the TPCH, TPCDS benchmarks. And they field tested Azure Synapse Analytics, formerly known as Azure Sql Data Warehouse. And their conclusion is that it outperformed Amazon Redshift in 88% of all the test H benchmark queries. And it also consistently demonstrated a better price to performance ratio compared with Amazon Redshift, which what they found is that costs 46% less when measured against Redshift, right? So Synapse is much more cost effective, and it also gives you more essentially bang for your buck, right? So there's Azure Synapse to date is the only platform that has completed the TPCH benchmark test at the 1 petabyte scale. So this demonstrates a massive concurrency, and all of this is captured and documented in a Scholar article, research article about the Azure Synapse engine behind the scenes, which is called Polaris. And you can read all about this in that article, in that research that was done in this paper. In addition to that, Azure Synapse Analytics makes it easy to both scale in and scale out your workloads for a better management experience. You can use a scale-in approach that allows more predictable cost and a simple way to allocate resources. And you can also scale out by increase the compute power of the different pools and clusters, as well as using multiple clusters with an auto-scale feature. Some of these auto-scaling, cluster auto-scaling, some of this is still in preview, but you can already see where Microsoft is taking this, an ability to scale in within your existing compute resources, as well as to create multiple clusters that can distribute and handle all these different workloads concurrently. There's another great example that Microsoft puts out there of a customer success story with Azure Synapse, and that is ABN AMRO. And they needed to decouple consumers from the data providers, right? They needed a way to make this data available without having this data tightly bound to a specific tool. And they were also considering doing a major investment in an upgrade of their Teradata systems. But they decided to test out Azure Synapse, and they were able to very easily, quickly develop some new value-added services for their customers, while they were able to save more than 70% of the cost, right? So this is a very awesome example of how Azure Synapse compares against some of these legacy systems like Teradata, and how you can quickly adopt Azure Synapse while taking advantage of some of the cost savings that Azure Synapse provides. Now, speaking of some really cool, awesome scenarios and use cases, let's talk about a little bit about Azure Synapse Analytics and some of the more real-time operational analytics features that have been made available. So if you're like many other organizations that we work with, a significant amount of data that you produce and that need insights for resides in operational databases, transactional databases like SQL Server, Oracle, MySQL. And historically, it has been nearly impossible to integrate operational data with analytical systems, right? So if you wanted to report on transactions that were happening on your invoicing application, your ERP system, you had to extract that data into an ETL, dump that data into a data warehouse or a data lake, and go through this cumbersome process, ETL process, right? Extracting the data, loading, transforming the data, to be able to put it in another repository, data warehouse, data lake, or database, right? To be able to report on. And so Microsoft took notice of this. The customers provided the feedback, and we also, as partners, provided this feedback to Microsoft and said, look, it's no longer feasible to be able to copy and move all this data around. There has to be a much simple approach to this. So that's what Microsoft set out to remove, that barrier, that complexity, and enabled a low-cost, cloud-native HTAP implementation with Azure Synapse Link. HTAP stands for Hybrid Transactional Analytic Platform. And essentially, it allows to connect or enable this in your source operational databases and make that available automatically sync with your Azure Synapse data stores. So it is a very easy way of just enabling, clicking a button, enabling that real-time operational analytics capability in your source database, and within minutes, that data, or within seconds, right? That data is going to be synchronized to the Azure Synapse using this Azure Synapse Link. So this is a very cool approach, very cool way of thinking, because you pretty much can eliminate your ETLs, right? That is what this service is meant to do. It's eliminate that barrier of entry. You don't have to go through an expensive, complex process of ETLing your data in. You can just enable this, and now you have real-time or close to real-time analytics on your data sources. So currently, this is capable within Cosmos DB. So if good news is we're using Cosmos DB, you can take advantage of this right away. But Microsoft is making this available in Azure SQL Database, of course, Postgre, MySQL, and MariaDB. So all of this is already in the roadmap, and I'm expecting that Azure SQL Database HTAP capability will be available within the next quarter or two. So pretty exciting news. Imagine a world without ETLs. I know a lot of you welcome that. I do. Although I love ETLing and I love all that data engineering, but we want to get to the data as fast as possible without all of that processing. So yeah, so like I mentioned, Azure Synapse is available for Cosmos DB, and you can start previewing some of the integration with other of these other relational systems. And it really enables real-time operational analytics, right? Just by clicking a button, making it available. And this synchronization is happening close to real time. And the best thing of all is that it does not put an impact on overhead on those operational systems. It uses a lot of the underlying storage system and to be able to do that. And I encourage you to read a little bit more about Azure Synapse Link and the implementation of this HTAP technology. Really cool stuff. Now, in addition to that, not just the real-time integration, real-time ingestion of data and processing of data, but also the ability to ingest and process streaming data from some of these IoT devices, for example, without having the need to aggregate, stage the data, or bring that data into a batch pipeline. It allows about 720 gigabytes per hour of raw data coming through that can be used immediately and create rich insights on that streaming data set. And previously you would have to use like a service like Event Hub or Event Grid, IoT Hub to be able to handle this amount of data and be able to process and query. Now, Azure Synapse also allows you to tap into these streaming data sets, specifically, or in most cases, coming from IoT devices, machine telemetry, machine generated data, right? Really cool stuff. A good example of this capability, you can read about TechnoAlpine that used Azure Synapse Analytics to help ski resorts ensure that they're providing just the right amount of snow for their customers. So as you can see from the picture, TechnoAlpine manufactures these big machines that produce snow for ski resorts. And their customers wanted a real-time access to the data to make sure that they fine-tune the configurations of these machines to produce a better quality snow. And TechnoAlpine implemented IoT streaming datasets along with Azure Synapse Analytics to ingest, tons and tons of data and create smart predictions about, what is the best composition of the snow based on not just the operating factors of the machine itself, but also taking into consideration other factors like weather, humidity, wind, a lot of these other factors that contribute to better data quality snow. So if you like skiing and snowboarding and enjoying ski resorts, and you see one of these machines out there, now you'll know that Azure Synapse Analytics is behind these machines, making sure that you got really good, fluffy, powdery snow for skiing and snowboarding. So really, really cool application of real-time analytics. So, so now we're going to talk a little bit about machine learning, and we're going to just discuss some of the integrations with Power BI. How can you leverage your Azure ML models or other third-party machine learning AI platforms and just integrate it all within the Azure Synapse experience. So with that said, let's take another quick 5-minute break, and we're going to come back and talk a little bit more about ML, Power BI, and some really cool topics, and then we're going to jump into our lab together. So I'll talk to you in about 5 minutes. All right, so we are back, and let's run through this last couple of slides, and then we're going to jump into the workshop. So before I jump into the workshop, into the slides, I want to make sure that everybody has access to the lab. You should receive an email from our team where you can register for the lab. And if you haven't done so, please proceed, because it takes about probably like 10 minutes at most for that lab to become available. So while we're going through this last couple of slides, then you should have that environment set up and ready to go. So check your email, and if you have not received that, Madison, one of my great colleagues, team members supporting me today, she has posted that in the Q&A section. So just click on that link and use that activation code so you can access the lab portion. So thanks, Madison, for that link. All right, so with that said, let's continue in our presentation section. So now I mentioned the capability of being able to run machine learning models within Azure Synapse. And all of this, again, within the Azure Synapse Studio, that allowing data engineers and data scientists to collaborate more seamlessly, right? Without having to have these handoffs of data and instead coming together into a single seamless development experience. With this experience within Azure, within Synapse Studio, either both data engineer, data scientists can use a code-free and code-first experiences to train models within Synapse, powered, of course, by Azure Machine Learning, Azure ML. So in this environment, data scientists, data engineers can create SQL queries that are highly scalable, as well as work with notebooks that offer a more collaborative, code authoring experience for these complex predictive models, right? So whether you use, the pre-built models that are available in Azure ML, like all of those regression, decision trees, available in Azure ML, or you can decide to build your own using Python, C#. You can automate all of these machine learning tasks within Azure Synapse within minutes without having to move data around, all within the same development experience and leveraging the same data stores, the same data sets in Synapse. That definitely has helped some of our customers because traditionally they've had to move this data into different shapes, formats, in different repositories to make sure that those reads are scaled and perform adequately for these models that often have to churn through the data multiple times to make a lot of iterations, especially like some of those classifiers that need to look at, apply some tags on a row by row basis, sometimes even a column by column basis. So those are very compute intensive but also requires a lot of disk IO, right? Be able to scale those reads and writes as well. So this often has required dedicated, resources, compute and storage resources. Now all of this can be available along with your traditional data pipeline, data warehousing, data lake processes, and be able to scale them on demand and integrate them seamlessly with Azure ML. Really, really great capabilities, and I think this is going to be a game changer for many years to come because everything comes together in one place. So I just want to take a quick minute to talk about this notebook development environment for code authoring capabilities within Azure Synapse, and specifically in Synapse Studio. This enables that code-first approach or more heavy-duty coding experience to machine learning model development that allows you to use your favorite language, right? Like PySpark, Scala, C#, or even the Spark SQL endpoint, and be able to for you to change between the different languages. Sometimes you'll see in notebooks, you start with a Scala or a PySpark script, then you apply some type of C#, based algorithm based application or program, and then you change back to a SQL, and then you change back to Scala. So all of this is possible because Azure Synapse Studio supports these different programming languages, these different kernels that you can use depending on your favorite or the most appropriate programming language for your use case. And on top of that, one of the cool features that I really like is the implementation of Intellisense. So if you're not familiar with Intellisense, you might have seen this in Visual Studio Code or Visual Code, as well as SQL Server Management Studio and some other tools that Microsoft has implemented this. And that is essentially allows you the auto completion, right? So when you're typing a command, typing some function, it recommends, what or gives you a list of the functions or sub functions that are available, and makes coding a lot easier, right? With that Intellisense. Now, notebooks is not the only place where the Azure Synapse team gives you these options in terms of how to build your models. So not just in languages, but also in data formats, data types, right? So not only you can work with PySpark, Scala, C#, SQL, you can also work with many different data types and types of data. So, one of the most common file types out there is Parquet. I definitely recommend using Parquet, especially if you're dealing with lots of volumes of data and a lot of use cases where you need a selectivity within the data that you're churning through, right? Parquet, really great file format to work with, especially for machine learning, AI type of workloads. But in addition to that, it supports, org, it supports CSV, supports JSON, XML, and even more of these unstructured data sets like images, videos, voice, and be able to query those files based on the metadata, or even do very more compute intensive processes, pixel by pixel type of programming, right? Or processes that are compute intensive. So you have all these choices, all this capability within Azure Synapse around your ML efforts. And the great thing about this also is that if you don't have or you're not customizing or developing your own ML model, you can simply use a nice feature that Microsoft has made available in Azure ML called Automatic ML Data Exploration, that actually chooses or recommends the best predictive model possible based on the data attributes and features that you have in your data. So it's a really, really cool way for those data analysts, business analysts that perhaps are not formally trained as data scientists, and makes this capability available to common day business user, right? So this really democratizes the access to some of the data science, ML, AI capabilities available within Azure. And the best of all, they don't need to even write any type of code, right? They just point the data to the Azure ML auto learning experience, and it recommends what is the best algorithm to achieve the outcome they're looking, right? So this could be a quick prediction of what is the probability of a customer purchasing this product, right? It can create that prediction for them. Or what is the forecasted revenue or sales amount given all these transactions, right? It can do all that regression and provide the forecasting or trending for them, and recommend the best model based on the data, right? Knowing that not all data has, has great data quality. There might be some gaps, so you may recommend a different model based on the actual data made available as part of the training process. And like I mentioned, not only the tagging, classification of data, prediction, but also the ability to score the best algorithm to use without really needed to have a lot of domain knowledge, experience, and training. All of these with a very familiarized, perhaps SQL-based endpoint, or integrated within Synapse Analytics. So, one of the great use cases for this is more of this real-time access to predictive models, real-time predictions. And there's one good example of a customer success story with AmerisourceBergen. And again, there's great information out there on the Microsoft Customer Success Stories page. And with Azure Synapse Analytics, AmerisourceBergen were able to democratize analytics for everyone. And I'm talking about everyone, even frontline workers, workers that are in those distribution, supply chain floor, that allows them to expedite and route and be more efficient at this packaging and mailing distribution of pharmaceuticals, which is the industry they're in. And AmerisourceBergen needed a centralized platform that their business users could run without the need of data engineers at every step and having to develop all these, right? With Azure Synapse Analytics, it really provided this frontline business users to provide a self-service platform to have better business outcomes, right? And it created really a democratized way of accessing some of these predictions in close to real time. Now, and of course, if you have all these great capabilities, but if you have no real insight, real understanding of them, it doesn't really create a lot of value. So we talked about the continuum of analytics, that journey of analytics in terms of the technical capabilities. However, you can also think about analytics as a spectrum of time or different maturity stages over time. And typically you start by answering questions of what happened, right, and why. But can you really predict what will happen, and how can you influence or how can you affect those outcomes, right, of what will happen in the future? So that is where we're talking about, descriptive analytics, predictive analytics, and then prescriptive analytics. So descriptive, predictive, prescriptive. How can you explain the past? How can you explain the future? What can you do to affect the future, right? So this is a nice graph that you can see clearly that you start with hindsight, you get insights, and then you have foresight, right? And as you move along these different stages or these different analytics continuum, it adds more and more value back to the business, because now they can optimize and they can be more efficient on achieving those business outcomes. But business intelligence, data analytics is essentially the pillar, right? It's where every organization starts, and that's where you need to start to start maximizing the value of your data. And as you move along in your continuum, you are able to incorporate more and more data faster and be able to create insights faster and be able to anticipate and react to market events, marketplace events, right? Now, one of the natural journeys into any analytical journey is the ability to report back and be able to visualize data and be able to integrate this with other capabilities like predictive analytics, prescriptive analytics, so descriptive, predictive, prescriptive, in a single platform. So this is where you get a lot of your value, right? Ingesting data, processing data, transforming data. Yes, that has a lot of value, but the end goal is not, having huge teams of ETL data engineers. The end goal is to bring that data, those insights back to the business in the form of some type of dashboard report, typically, or some type of prediction that allows them to make better decisions, right? And this is the great story of Azure Synapse, ability to bring those two worlds together with integration of Power BI and Azure Machine Learning. The great news is that you can use Power BI right there from Azure Synapse Studio, and I'm going to walk you through that example in our lab coming in a few minutes. And this has really been a great way for organizations and some of our customers to deliver all these insights in that centralized, unified location without having users to go through PowerBI.com, having to embed those reports in their own portal, their own application, or SharePoint, all within Azure Synapse. So you go from ingesting data, processing data, modeling data, querying data, all the way to visualizing data, right? Right from Azure Synapse Analytics using Synapse Studio. One of the great feedback that Microsoft has gotten, and also ourselves have gotten from our customers, is the return on investment that this has provided back to the business. Not only in the reduced cost or more control cost, but also the usage of the data and be able to scale all of this pretty much without limits or any concurrency performance issues, right? One of the capabilities that Power BI offers, as you may be aware, is the ability to query data directly from the source without having to, ingest that data into its own data stores, bring and import that data into Power BI. And that is possible through the use of direct query. So Power BI connecting directly, querying directly the data directly from Azure Synapse Sql pools, and be able to just retrieve that data at report runtime without having Power BI to process and churn to that data, right? So direct query has enabled some of our customers to report on massive volumes of data at scale. Really, really great capability with Power BI. Synapse and the use of data lake storage and some of these common data models. So like I said, a lot of our customers and some Azure customers have already provided some feedback. And also this organization called Forrester Research has already made a study on the return on investment and total cost of ownership of Power BI along with Azure Synapse Analytics, and which has brought ROI to many organizations in the 250% range, and lower total cost of ownership, right around 26-27%. So really great study and research around the ROI and total cost of ownership by implementing Azure Synapse along with Power BI. One great example, really quick, is Procter & Gamble. They were able to implement Azure Synapse along with Power BI, and they were able to make faster, more accurate decisions by combining Synapse, Azure ML, Power BI, and making all those insights available to the user in a nice visualizations of Power BI. So really great example. I encourage you to look at it. And then just to make you aware that Azure Synapse is available pretty much all over their data centers. Some data centers are coming up where they're deploying Azure Synapse along with Power BI, but pretty much they're generally available globally. So great, wherever you are in the world, not only US, but also other areas, Europe, Asia, Africa, etc. So in addition to that, Microsoft has made a lot of investment with their partners and has already created connectors, specialized connectors from Synapse to some of these third-party tools and platforms. So if you're using any of those platforms, you can still leverage Azure Synapse for those without having to re-platform, redo your architecture. You can just plug some of these third-party tools components within Azure Synapse seamlessly. Now, before we go into the hands-on lab, I just make you aware that there's a ton of documentation, ton of tutorials, ton of self-guided labs, including the one that we're going to go through today in the Knowledge Center. And so once if you plan to test POC Azure Synapse in your environment, you will see that link available, and I'll show you where it is. And it gives you not only examples and some tour or capability of Azure Synapse, but it also actually gives you some data sets, publicly available data sets that you can incorporate and start working and playing around and learning Azure Synapse. So Knowledge Center is a great resource within Azure Synapse that will help you come up to speed with Synapse fast, quicker. Also, I want to make you aware that the Azure Synapse team has made available very compelling accelerators or starters so that you can expedite the adoption, implementation of Synapse along with other platforms and technologies, or expedite the migration of those capabilities from these third-party tools and platforms to Azure Synapse. So Microsoft Azure Synapse team has made available accelerators and packages to integrate or migrate from SAP, Qlik, Informatica into Azure Synapse. And specifically, there's some incentives that you can talk to your Microsoft rep about, or you can talk to us and we can help provide you more information on how to take advantage of incentives where Microsoft will pay for a part of a POC or give you a discount on your Azure consumption so that you can do some of these POCs, proof of concepts or proof of values with some of these third-party platforms and tools, including Qlik, SAP, Informatica, and some other toolings like Tableau as well, where you can take advantage of those incentives for proof of concept, proof of values, but most importantly, the ability to take advantage of heavily discounted rates for migrating to Azure Synapse. As a matter of fact, there's a great incentive that expires pretty much in 6 days, May 31st, where you can save up to 76% of your Azure Synapse consumption by migrating to Azure Synapse. It doesn't mean that you have to be fully migrated to Azure Synapse. I think that as long as you start that project and talk to your rep, talk to us, we can help you get those heavily discounted rates for Azure Synapse. So take advantage of this offer before May 31st, because I'm not sure if they will extend it or have it available after that. All right, so with that said, we're gonna jump into the hands-on lab. Make sure that you register and you have your environment set up. I'll walk you through that step really quick as well. So we're gonna take a quick 5-minute break, and then we're gonna start with the hands-on lab. So I'll talk to you in 5 minutes. All right, so we are back and ready to start our hands-on lab. So I'm gonna change my screen here. All right, so everybody should be able to see my Azure environment. So one of the things, when you configure your environment, you register, and you should get that email or a button there to launch your environment. You will be able to log into a virtual machine, which is what you see here on the left. And if it's not running, if it gives you a message that it's not running, go to the virtual machine section and click the start button. And that will run this virtual machine where you're going to be able to log in and be able to connect to the Azure Portal in this sandbox environment, training environment that Microsoft has made available. So with that said, I want to make sure that everybody has access to it. If not, please let me know through the chat. I'll monitor it, and Madison will let me know if there's somebody that's having issues, and maybe we can help you troubleshoot while we're in the lab. So with that said, also, you can remove this section off of the window, in this window, so that you can have a little bit more real estate by clicking on this button down here called split window. That would allow you to undock these windows from the screen. And then also, if you notice on this screen, there's a lab guide, which we're going to walk through together. Explains to you, the data that we're going to be working with, and then in the next couple of pages, gives you a step-by-step tutorial, step-by-step guidance on working with the tutorial that we're going to be working with. So I'm going to be using this as my guide. And then here under environment details, if you click on that, you'll see the username and password that you want to use to connect to the portal. So if you haven't done so, launch your virtual machine. I'm going to separate out this window. And you should be able to log in without having to provide credentials. But if you're prompted, look at your environment details section, and there you will find the username, which will be something like ODL_user, then a number at ms-azurelabs.onmicrosoft.com, and then right behind that, the password. So you can just click on the under action, those two buttons to copy into your clipboard and paste it. Once you log into your virtual machine, what you want to do is you want to launch this Azure Portal shortcut or your Microsoft Edge browser. If for some reason that shortcut is not there, this one, oh, sorry, I clicked. Give me 1 second. I closed the VM by mistake. Give me 1 second. All right, I think I have recovered my, yep. If you close it by mistake like I did, go to your email and you should see an email with the a button to launch your lab from there. So don't click on this window, you have to do it this window. So I was saying is if you don't have that portal.azure shortcut here, you can simply go to portal.azure.com. And if it asks you for credentials, type in or copy and paste the credentials under your environment details page. What I did is I saved mine, so I don't have to be entering. So my credentials are there already. Let me check, make sure that everybody is okay. Nobody has any questions or issues, so we can proceed. All right. So once you log in, you can click under resource groups down here. And in that resource group list, you'll see one resource group called the Synapse AI AD. If you click on that, you will see all the different resources that are available for this lab. The one that we're going to be working on is with the Azure Synapse Analytics workspace. But before we do that, I want to make sure that you start your Sql pool. So in the list of resources here or services, click on Sql pool 1. And if it shows as it may show that it's not started, so you might want to click on start. So because it takes a little bit of time for that to start, like 5 to 10 minutes sometimes. So make sure to start it if it's not started. If you go back, also want to make sure your Spark pool has been started. And if you see succeeded, that means that it started and it's available. So just check on both your Sql pool 1. Make sure this is in a running state. Or it shows online here. If not, you click on a button down here to start or resume that pool. As well as your Spark pool, make sure this shows as succeeded. If not, then you will have to start it manually. All right, so now that we have our Sql Spark pools started, make sure they're online, let's launch the Synapse Studio. So in the resource group, we have this ASA workspace that we can click, and that will open the blade where we can launch the Synapse Studio from this shortcut. So you can also click or copy, maybe you want to bookmark this. If you want to go directly to Synapse Studio, you can bookmark this workspace URL as well. So in this case, I'm just going to click on open in that shortcut. And that will launch the Azure Synapse Analytics Studio, right, where we're going to be working, going through these labs. All right. So when you launch Synapse Studio, you see that there's a landing page, and then, like I mentioned, somewhere here should be our. If it asks you for cookies, just accept. If you go to Learn, you should see that Knowledge Center, where you can see some of the examples. You go to a guided tour, and then start using some sample data. So this is great if you want to kind of explore Synapse on your own, start learning. So with that said, you'll see here on the left several shortcuts. You can expand or collapse this section by clicking on that arrow. And you can see home is essentially this landing page. Data is where we're going to use to connect to our workspace databases, as well as our linked data stores. In this case, we have a blob storage, we have a data lake Gen 2, and we have integration data sets. We're going to come back to those in a little bit. I just want to make you aware that there's a workspace section, a linked section. Workspace is typically your SQL pools, SQL databases, and linked essentially are your linked data stores. Could be data lake, blob storage, could be other data stores out there, as well as your integration data sets that are created out of this integrate section here. So the next section is your develop. And essentially this is where you're gonna go to run or write SQL scripts, develop notebooks, develop also data flows, and work with Power BI. And this is the Power BI integration that we're gonna go over in a little bit. Then you have your integrate section. And if you have worked with Data Factory, this is essentially the ability to create Data Factory pipelines. So essentially, this is Data Factory integrated within Azure Synapse. Then you have your monitor section, which allows you to monitor your data pipelines, all your triggers or schedules, and all of the other monitoring sections for looking at what's running, what ran in the past, the success of those executions, etc. And then manage, which allows you to do some configurations like some of your integration runtimes, your SQL pools, Apache's Spark pools, integration with Azure Purview, which I talked about for security and compliance, data lineage, and all of that data-related governance. Access to your link services that allows you to configure connection strings, usernames, passwords, stuff like that. And several other configuration settings, including the ability to integrate with a Git repository. So really, really cool settings there to manage your code, manage your connections to your data, your access, etc. All right, so with that said, the first thing that we're gonna do is we are going to start exploring the Sql experience, the Sql Script, Sql development experience. So for that, we're gonna do is we're gonna go to Data, and we're gonna go to our Linked tab, and we're gonna expand our Azure Data Lake Gen 2 storage, and then your ASA workspace. So this is the Azure Data Lake Storage Gen 2 workspace that has been integrated for us in this Synapse deployment. The next thing we're going to do is we're going to click on this WWI folder, and we're going to start working with the Parquet file. So there's two extracts that have been made available for us. There's a FactSale export into CSV files and another export into Parquet. For this initial exercise, we're going to be working with the Parquet version. And then we're going to do another exercise with CSV so you can see the difference and the benefits of working with Parquet. So we're going to double click on Parquet, FactSale Parquet. We're going to go to this first folder, 2012, quarter one, invoice date key equals 2012-101. And then finally, we're going to work with this particular file. If you notice, this is an extract from the FactSale that has been partitioned by year, quarter, date, right? So these are the individual individual invoices that correspond to January 1st, 2012, right? So once we arrive to the file that we're going to be working with, we're going to right click on that file, and we're going to select new Sql Script, and we're going to select top 1000 rows. When we do that, you can see that it automatically created a select statement using an open row set to the file that we right clicked on. And it automatically detected that this is a Parquet file, so it has the serializer or a connector built in to be able to parse and read Parquet. Once we do that, let's click on the Run button, and it's gonna start querying our that Parquet file and bring us that result. So it's going to take a little bit of time as our SQL endpoint gets up and running. And once it runs, you'll see that it executes that. Now, because it was the first time that we were running this and using that pool or the cluster, it took 14 seconds. If you run this again, it should take way less. Depending on the resources available, because we're all sharing some resources together, but this should be relatively quick the second time, third time that you execute. So hopefully this is not a symptom of what happened last time, where the infrastructure team that provides this started decommissioning a bunch of resources ahead of time. So probably not. All right, so this should take relatively quick, 10 seconds or less. Right now, it seems like there might be some environmental situations, so hopefully we don't experience an issue we experienced on one of our previous labs. But you can see the results that we got from it, and we're able to query and see the data relatively quick, right? Now, the next step is we're going to instead of selecting the top 100 rows, let's find out how many rows of data are we talking about. So we're going to change this to a select count star instead of a select top 100 or 1000, and we're going to run this and see how many rows we are dealing with. We can see the result that we're dealing with 32,000 rows from this individual date, right? But we could change this a little bit and say, all right, I don't want just data from a particular file. I want data for an entire quarter, for example, right? So if we're not interested just in a particular file, we can actually change our script to reflect that we want data retrieved not just for a day, but for the entire quarter. And we need to specify that we want all subfolders with an asterisk, means all subfolders within the Q1 folder and all within those individual folders, right? So essentially, we're traversing that, we're specifying that we want all folders within the 2012 Q1 file namespace or file hierarchy. So let's run that. Before we had 32,876 rows in just one file. Let's run this and see how many rows of data are we dealing for a particular quarter, right? For the entire quarter. You can see that the results are really quick, right? 2.99 million records across that entire quarter. And we can keep going, and we want to say, okay, how about the entire year? How much data do I have in the entire year? So we can run that and see how much volume of data we're dealing with. So again, this is a very quick way. If you have large volumes of data and you want to be able to query all this data that is stored in files and do it in a very scalable manner using this SQL endpoint, which uses the SQL pool. So across an entire year, in this case for 2012, we have about 11,909,000 records, almost 12 million records, right? And we are able to do those counts really quick, 14 seconds. And just keep in mind that what we are querying here is not a database, but rather files that are stored in our data lake store, right? Particularly files that are stored in Parquet format, which is a really efficient and fast file-based storage that I recommend for you to explore. All right, so not only we can read data from Parquet, right? We can read data from CSV files. Now, remember that when we queried this data for this particular day, we were able to retrieve not just the data itself, right? Not just the rows of data, but we were able to retrieve the metadata. And by that, I mean, we're able to retrieve the column names and data types, right? Directly from here. So we have the nice, columnar format of our data with all the column names. And if there was formatting, with a nice formatting, right, in each. The reason we're able to do that is because we're using this Parquet file. And like I mentioned, this is one of the preferred file formats to use nowadays, because it not only stores data more efficiently, but it actually stores metadata, the column names, the data types, and a lot of other metadata information. And it allows you to be very selective if you're only interested in a subset of the data in those files. It only reads efficiently the rows that correspond to those files. It doesn't have to read the entire file. It has it's very efficient at reading subset of even within a file. So now let's explore how this looks with using CSV instead of Parquet. Notice here, it's a very simple script. Select a 100 in this case from open row set, point to this file, specify the format, which is Parquet. We get our results. Now let's explore how this looks using CSV. So if you go back to your data linked tab under WWI, you can go to you can click here to the WWI in the breadcrumb up here, and you can see that we have that FactSale CSV folder. So what we're gonna do now is we're gonna query the files that are in this folder. And for that, we're gonna go to the Develop tab on the left. And we already have this pre-built, pre-written script for us, so that we don't have to type. So we're gonna click on under Develop, under Sql Scripts, this exercise 1. And this opens a script that to read data from that same Q1 2012 folder that we worked with. Now, the difference or something that we need to make sure we do is we need to make sure that we're connected to our SQL pool, in this case, SQL pool 1, and that we're using the, sorry, not the SQL pool, but the built-in serverless. By default, it defaults to SQL pool 1, which is the dedicated resource. We're going to use instead that serverless resource called built-in, and we're going to use a database called the SQL On Demand 01. Okay. This is just so that we have like a scratch database. This is not meaning that this doesn't mean that we are going to be reading from this database. This is just a requirement to be able to use some of the temporary tables, some temporary objects, and temporary cache from this resource, and particularly this database. But what we're doing here is we're reading from a CSV file. As you can see, we're pointing to the CSV folder right here, to this particular subfolder, 2012 Q1. In this case, we're specifying a format of CSV, comma separated value. We are also specifying what is the field terminator, what is the field quote for those strings that are quoted, and where does our data start. In this case, this is a CSV file that has the column names on the first row, and the data starts in the second row. So this is how we're specifying where should Synapse start reading that data from, right? Then in addition to that, you can see that not only we're specifying some of these settings for that particular file, but we're also specifying the metadata, right? The data type and the column names. Now, let's run this and let's look at the results. So this might take a little bit longer. And the reason it will take a little bit longer is two reasons. One, because it's using this serverless resource, which when it's not in use, it essentially goes offline, goes to sleep. And once somebody executes a query using that resource, then it brings itself up online makes the resources available, and then executes your queries. So it's going to take a little bit more time to get those resources up and running. Now, in addition to that, it's a little bit slow as well because it is reading from a CSV file. And CSV files mean, if you read from a CSV file, it essentially reads the entire file. It doesn't have that selectivity that Parquet has. And also it has to apply this formatting and this structure, right? It is not built in. Now that we execute it, we see that we get the exact same results, right? 2.99 million records from this CSV file. And, that's pretty much the exercise here. So you can see the difference on how easy it is to query a Parquet file versus reading from a CSV file, which requires additional configurations, original structure, metadata definition. And you can see that the query time, it's a little bit longer because CSVs are not optimized as they are with Parquet. So let's see, anybody has any questions, any comments? Everybody was able to run through those that exercise? If not, please feel free to write your question here in the chat. All right, so the next exercise, we're going to close these two windows. We don't need to save them. We can discard them. The next exercise is I'm going to show you how to work not just with the SQL endpoint or a SQL query interface, but instead how to use notebooks, right? We're going to use PySpark to query this same file that we were querying. But instead of a SQL endpoint, we're going to use a notebook interface, and we're going to load this file into a data frame. So if you don't have this window open, we need to go back to data. Then we need to go back to our linked resources and back to our Data Lake Gen 2 WWI folder. WWI, by the way, stands for Worldwide Importers, which is a fictitious company that Microsoft created and added some sample data sets for you to learn. So in the WWI folder, we're going to go back to Parquet, back to that 2012 folder, Q1, and back to that invoice date of January 1st, 2012. Once we arrive to that subfolder, you can see that file. We're going to right click on the file again. And instead of selecting a new Sql script, we're going to use a new notebook. And we're going to create that new notebook and import that data into a data frame. Whoop. So when you click on new notebook, load to data frame, it automatically inserts the PySpark command and loads that into a data frame. Now, before we go any further, want to make sure that we are connected to the right pool. In this case, it should be the Spark pool 01, and that we select the language that we need to work with. In this case, the PySpark Python language. Once you select these two settings, then we can proceed to execute this. So I'm going to run this cell. And the way you run it is by clicking on this green button here that says, run cell. In notebooks, you execute cells. In SQL, you execute SQL statements or SQL blocks, right? In this case, think of this as a window that selects that particular code that you have specified here. So we're going to click on that. We're going to let that run. It's going to take a little while again. While the Spark pool nodes get up and running, and it parses through this command. So while that's doing, that is running, let me just walk you through what's happening here. So the first thing you'll see here is this magic command, or magic keyword called specified with these two percentage symbols. So this is just telling the Spark cluster that we're going to execute a PySpark command. Now, you don't have to really specify that. If you have that Python PySpark language selected, it automatically defaults to PySpark. But if you want to jump between PySpark and C# or Scala or Sql, Spark Sql, then you need to specify what the kernel or the language that you're going to be using in this cell. In this case, PySpark. The next thing is we're specifying a function called spark.read, and then specifying that we're going to load data from this path. In this case, this is our data lake store path, and specifically specifying this particular Parquet file under the 2012-0101 folder. And we're specifying that the format of this file is Parquet. So this is a built-in method, a built-in function that allows you to read from special type of file formats like Parquet into what's called a data frame. What you see here, df means the data frame. You can name that data frame whatever you like. Could be df1, df2, could be my data frame. You don't need to specify that as df. Df is just kind of the standard way in lieu of any other word. And think of that as a variable. So like you're specifying that you are loading this data into that object, into that variable. In this case, it's a data frame, right? In addition to that, you can see that we have also another command here called display from our data frame limit 10, which means just display the first, just display the 10 rows. Not necessarily the first 10 rows, just 10 rows, right? And as you can see, it loads the data into the data frame, and now it's displaying this in only the 10 rows that we specify. Okay. Now, so in addition to that, these are just 10 rows. So let's see how this looks like if we specify 1,000 rows, right? So let's change that to 1,000 rows and let's re-execute. This execution should take a lot less because we already have a session established. The cluster resources are up and running. And so now the results are much quicker, as you can see. And we can go on in 10,000, a million rows, and you'll see that the execution from those are quick because we already have a session, we already have resources available. Now, this display command simply shows you the data in a table format. But one of the great features available in Synapse Studio, which is what we're working on, is the ability not only to view the data in tabular format, but also view it in a more visual way, right? Without having to export the data to Power BI or some other tool. So the way you do that is you change the view to chart instead of table. You change it to chart. You also have the ability to export the results into like a CSV, JSON, XML format. But in this case, we're just going to view it here interactively using this chart component. Now, as you can see, it tries to visualize this in a chart, but it doesn't know really how you want to visualize it. So we're going to customize that by clicking on these view options up here. So it's this little icon on the top right. And that opens a window that allows us to change the fields that we're going to be visualizing. So in this case, we want a bar chart, which is what we're looking for. But instead of the cell key, we're going to use the customer key. So if you unselect that and select customer key on that key field, then under value, instead of the cell key, we want to select the city key. And then the series group, we're going to leave that blank, and then count, the aggregation will be a count. And then after that, we click apply. So now we can see that it created a bar chart, which is a horizontal bar chart. We're going to change this to instead of a column chart so that it matches the example. So let's click on column chart and click apply. So now we can see that we have, our data visualized, and unfortunately, it seems like we have a value, a city key that is like skewing our data, right? Because there's a lot more records here with this particular city. But you can see, also that there are a lot of, I guess, empty rows with the particular city. But we can start playing around with many other, settings. Let's see if package has some type of, I think it's the same, maybe profit instead of a count. Let's do a sum or an average, right, of profit. And there now we have a better looking chart where we can see what's the average profit by customer, right, over all different customers. We can see at a glance that this particular customer 325, has been the most profitable customer. So you can see, right, how Synapse Studio allows data analysts, business analysts, some managers to quickly tap into the data stores, data sets that have been made available by our data engineering team, be able to bring this into a SQL-like interface using the SQL pool, or say, or change in that to say, well, I don't want to use with a SQL query. I'm more proficient with PySpark, and I want to see consume this data with a using PySpark instead. And you can see how quickly you can interact with the data without having to export this data and import this into another tool, or have to move data from one data store to another, all within the same development experience. Okay. Now, there's some other exercises here that are meant to be more for showcasing the performance capabilities of Spark, but we're gonna move to the next set of exercises in the interest of time, so that we can get to the more of the compelling exercises. Now, the next part is going to be around being able to apply some transformations and some integration with the Azure pipelines. So we can close this quick example, close any spare changes. And in this example, which is exercise 2, we're gonna we can close this window as well. We're gonna work with our pre-built scripts that will allow us to work with our data. In this case, what we're gonna do is we're gonna let's see, click here under develop. And we're gonna work with a notebook. So as you can see, you can create a new notebook starting from your data lake or your data, right? Selecting a file, selecting a folder, and then launching a SQL script or a notebook. Or you can go directly to develop and click on this plus sign up here and selecting notebook. So at this point, this is a new notebook. We need to specify what resources we want to work with or attach to. In this case, we're going to select our Spark Pool 01. And in this particular example, we're going to work with Scala. Scala is the native programming language that's based on Java that is one of the preferred languages to work with in Spark. As well, PySpark and C#, all of those are great languages, but Scala is sort of like a lower level programming language that has native connection to Spark. As a matter of fact, some of these other languages like PySpark, C#, Spark SQL, those are actually built on top of Scala, and some of those scripts queries are running Scala behind the scenes or translated to Scala. But PySpark, Spark SQL, C#, if that's your preferred language, doesn't mean that you have to learn Scala. Those languages have been ported into Spark and Synapse and perform really well. But Scala is the most lower level programming language. So once that we select that, we're going to create a new cell, which we have here already. Or we can create a new cell if you don't have one. Let me make sure we're 100%. Yeah. And in the examples that I'm following here, as you can see, we have some scripts that we're going to copy. So make sure you have that available. And we're going to copy the first example, which is the data lake that we're going to work with. In our case, we need to replace this section, WWI at your data lake name. And we can extract that from our environment details. And in this case, if you look at my storage account, it should be this value, right? So we can click on action, copy that, and replace that in here. Okay. Sorry, this should be WWI at your data lake. So it should be this portion. So WWI at ASA data lake, because we need to specify that it's the WWI container or folder. Okay. So if we run this, the only thing that is happening here is that we're specifying that we want to use this library, the Sql Spark session library, and we're specifying that we have a variable called ADLS path that will hold this path, this value for us. That's the only thing that's happening, right? So you will see that there's nothing displayed beneath this cell. It is just applying this value into this variable. So we're gonna let that run. It's creating a new Spark session, so it takes a few minutes, a minute or two. All right. So the only thing it's telling us that, yep, I got it. We are importing a library and we're specifying this value to that variable. Cool. The next step is we're gonna add a new cell. So when you click on the plus button here, click on code cell. And this opens up a new cell. In your lab guide, you'll see that there previously, actually, let me check if they still have that, because this has changed quite a bit. So yeah, so before, if you hover over this section, you would see two buttons here, add code or add text. That has been recently updated to use this plus sign down here instead. So if you're trying to find those two buttons, you will not find it. You would just have to click on this plus sign. Now, one of the instructions was to remove these preview features or disable that. And I think that this is a preview feature now because in the previous workshop, those two buttons down here were still available. So I believe this is preview feature, but I would just encourage you to try all these new preview features because they in my opinion, they improve your experience with Synapse Studio. So once we have the new cell, we're gonna copy the next script below, which is this one. So we're gonna just copy that. And we're gonna paste it in that new cell. And what we're doing here is essentially we're saying that we are going to read from a file that has a format of CSV. We're specifying that there's a header, so header is true. We're also specifying that we don't know the schema, so please infer the schema for us, meaning infer the column names, infer the data type, infer the delimiter. Although the delimiter, actually we're setting it here. In this case, we're setting the delimiter, or the separator, but we are having Spark infer the column names, data type, and all that. And then we're saying that we're loading data from the ADLS path, which is that variable, right? You can see how you reference a variable, $. S means that this is a what's the name? A little string that we're specifying, a string that needs to be built out of this, including the ADLS path. So this path right here, along with concatenating this with this particular folder structure. Right? And then once we load that into this sales data, not data frame, in Spark or Scala, it's called an RDD. It's essentially similar to a data frame, but it's RDD. That's the proper name within the Scala programming language. So now that we specified that into this RDD, or we can call it data frame, doesn't matter. We're gonna show 5 rows, and we also gonna print the schema that it inferred from here. So let's run this whole cell. And it should be loading just one file. Oh, sorry, all the files under the 2012 Q4 folder. It will show us 5 rows. Doesn't mean the first 5 rows. It will just grab 5 rows, right? So this is not top 5 or anything like that. And then it's going to show us what was the schema that it inferred from that file. If you wanted to see what's happening, we can expand the job execution. You can see, that it's running 2 executors with 8 cores. We can see the schema. So sale key, city key, customer key, along with along with 5 rows of data. Right? Now it is not pretty because this is essentially the default view, which is very text-like, and this is meant just to. This is a command, the command called show. Very rudimentary, very just a quick way to kind of make sure that you get results back, make sure that it inferred the right schema, the right data types. But if you notice a little bit closer, there are some data types that perhaps it didn't get right. I think, let's see, actually, I did a good job of specifying those in this case, yeah. So it's able to sample some of the values for each of these columns and infer that schema. Now, the next exercise is, all right, that's great. We are able to read data from those files in those folders. Now let's save this data into a database, right? So we're gonna copy the next script. And I'll walk through that script in a second. So we're gonna click on the plus sign and select code cell. And in this script, although if you can see here, we are working with the Scala language, we are going to change the context or the language that we're going to execute this script by specifying this magic keyword called %% Spark. And that means that we're going to start using the Spark Sql language in here. The first thing is we're going to import these specific libraries. And we're going to specify that our target table name is wwi_staging.sail in our SQL Pool 01 database. And we're going to store that in a variable called table name. Then we're going to specify here that we're going to write into this table name we specified here. And we're going to write only the first 10,000 rows. Okay, or 10,000 rows. Sorry. So that is essentially what's happening here. We're importing some libraries that are required to support this method or this function. And then we're simply going to write into this database, into this schema, this particular table called sail. So let's look at our data real quick. And let's go to our workspace. We can see that in our workspace, we have a database defined as SQL Pool 01, as you can see here, which is this one. If we expand that, let's expand tables, and we should see some of the tables that have already been loaded there. You will see that there's no table called sail under the WWI staging schema. So the schema here is WWI table name dim city, for example. We see that there's no WWI staging sail table. So let's run this, and after this, let's make sure that we see that table now in our database. So while this is running, you can see the steps of this execution, and you can see that it breaks this down into multiple stages, and eventually it completes, right? If we now refresh, the table is here. You can refresh by hovering over the, for example, in this case, the tables section. You see those three dots or periods or ellipses. And if you click on that, you will see the option there to refresh. So let's refresh and then scroll down. We should see now that WWI staging cell that we specified here now, right? So now what we can do is very quickly, we can just right click on this table and click on new SQL Script, select top 100 rows, and we can quickly see the results of our data, right? With the appropriate column names and the appropriate data types that we specify. You can see if you expand here under columns, you will see that it holds that metadata that was specified or was inferred by Spark. And of course, if you do a count star, you should see that it wrote 10,000 rows, because that's the how we specify, right? Only limit only limited to 10,000 rows here. Okay. And we can continue to, append or add to this table, and then now we can use and query this table for other type of development. Okay. Now the next exercise shows you so we can close this. We don't need it for now. We can close this card. Then next series of exercises shows you how to work with working with C#. And as a matter of fact, here in this case, this notebook, I'm not going to run through all this, but you can look at some of these examples of how can you use C# to read and write from in Synapse. Just make sure that when you work with a C# that you select the appropriate language. In this case, the .NET C#. If not, you will see some errors, right? If you don't choose the right language. So yeah, so you can run through this example and you will see that it also reads data from that path, and then it creates a table called cell feature. So I'm just going to run this really quick, and instead of running cell by cell, I'm going to click on this option here called run all, right? Instead of cell by cell. So I'm going to click on run all, and it will queue these cells. We'll run the top cell first, second, third cell in that sequence. And then at the end, what we should see out of this is a new table called the WWI staging schema cell C# _ C#. So let's wait for this to execute, and then we're going to refresh our data under the Sql Pool 1 tables. So that is starting a new session. Then it's gonna assign this, read this into this data frame. It's gonna show the first 5, and it's gonna print the schema, and then it's gonna read. It's gonna then write into this. I'm gonna write the first 1,500 records, or the 1,500 records into this table defined by that table name and connection strings here. So this is executing. We can see that it succeeded. It inferred the schema. It was able to retrieve some rows of data. And now it's executing the write stage, the writing stage. And we can see it succeeded really quick in about, oh, it's still running actually. But 8 of 9 tasks have succeeded so far. And there's 2 stages that it will run this through. And we can see 1 stage succeeded, and then the second stage below. It's in progress. All right, so that's still running. You can see also here the progress up here, the running. And when you hover over, it also gives you a quick information box. What is the session number that you're running? So this is great when you want to monitor and you have errors or some issues. You can go to the Spark UI. If you click on this section here, it opens that session. It gives you a lot more details of the activities, the job groups that are being run and executed. And you can even kill a runaway session. For some reason, it's just not completing. You can kill that from here as well. And then up here, you can see the different stages, the different configurations, and like different runtime and properties that have been configured, and the executors being used by that session, and what are the Sql steps that have been executed. So let's go back to jobs. It seems like that succeeded, 9 out of 9. We can close that, and we can confirm now that this cell is returning as succeeded. So if we go back to data, workspace, Sql Pool 1 under tables, we can refresh this. And we should see that new WWI_staging.cell C#. And just like we did with the other, we can now right click on it, new Sql script, select top 100 rows. And we should see those 1,500 records that have been loaded into the table. Right? So that's pretty simple. That's just to showcase the flexibility of the programming languages that you could use to read and shape your data, store it in a table in this case. and be able to query it right away using PySpark, Scala, C#, all within the same unified development environment, in this case, Synapse Studio. So let's close this, and we're gonna run to the next set of exercises. I'm checking here in the Q&A. There seems to be no questions so far, so I'm gonna proceed. Actually, let's take a quick 5-minute break, and let's come back to a 5-minute break. Let's come back to the last set of. Sorry, this is not opening up. Yeah, so let's take a quick 5-minute break. We'll be back. All right. And we should be, we're back and run through the next couple of labs that we have available. So in the next set of exercises, we're going to now start working with the integrate section. And particularly, like I mentioned, this is the seamless integration of a Azure Data Factory with Azure Synapse Analytics. Before I proceed, are there any questions? It seems like everybody is doing good so far. So let's go back to this. So this, if you're familiar with Azure Data Factory, you will see that a very similar development experience with Azure Synapse, right? With the exception of some new features like some of the specific Synapse activities. But all of the rest of the activities are pretty much the same, like the copy data, mapping data flow, some of the execute pipeline, lookup store procedures, etc. that are commonly used, right? In this example, it's showing two types of activities. One of them is a copy data activity and a mapping data flow activity or data flow activity. And what we're going to do here is we're going to read data. We're going to extract data from a customer, from a file that's sitting in our data lake. In this case, is a dim customer export or extract into our data lake. And we're going to sync it, or we're going to load it into a table called WWI staging dim customer ASA. Okay. We're going to pass some parameters. So you can see here where we have specified parameters in this activity, and we're going to pass this pipeline. It is like a system ID, system pipeline run ID. And then, as you can see, there are some mappings that are already done for us. And what's happening here is essentially we're grabbing for this column called WWI space customer space ID of data type integer 32, and we're mapping that to our sync or destination column. In this case, WWI customer ID without spaces, right? So we are mapping this to the specific columns in the table that we are sending this to. There's some settings here that can help with fine tune or optimize the run. We're not going to get into the details, but I just want to make you aware that you can change the parallelism and the data integration units, which allows the data factory to use more resources to execute this activity. For example, if we're talking about very large data volumes, we probably want to expand those data integration units to more than default, which or auto, which may be 2 to 4, right? Specify a specific set of integration units. Just keep in mind that if you're using these settings or changing the settings, there's a cost associated with it. So if you're running this in your environment, you know, each execution in every DUI, DTU hour, the data integration unit hour costs, right? Not much, but it could get up there if you're executing multiple of these multiple times. So that's the copy data activity. So we're just grabbing data from our data lake and inserting it into our table that we're staging those customers in. The next activity is a data flow activity. And with this data flow activity, we are passing those parameters, which are the system parameters of the run ID of the pipeline. If you double click on that activity, you'll see that you can open that data flow and start seeing what are the data activities that are happening in those in that data flow. And what's doing is very simple. It's grabbing a file that has the postal codes, and it's filtering those postal codes to only postal codes that are greater or equal to 9,000 and less than or equal to 98,000 or 9,800. And then it's also grabbing data from that staging table that we're populating, and it's joining it to that postal code filtered data set. And essentially, we have two sources of data. We have a postal code file. We have a DIM customer table. This data set is being filtered, and then we're using that data set here to join back to our customers. And essentially, it's doing an inner join, which results in customers that only that are in this zip code, right? 90,000 to 98,000 range. So essentially, this is using this data set as a way to filter our DIM customers. Then we are only selecting a particular set of columns. In this case, pretty much all the columns, including the postal code information. And we are exporting this or outputting this data into a data lake store, into a data set, what's called an integration data set called staging and rich customers. And we're also doing a outputting this data into a table, into a Sql table, right? So we are essentially doing a copy, sending a copy to a data set in our data lake store, an integration data set, and we are sending that same data into or a subset perhaps of that data into this table. Now notice that it is referencing this staging table, and that is the table that we are loading here, right? So obviously this needs to run first before this can execute. So what we're gonna do is just like you might be familiarized with in SSIS, SnapLogic, Alteryx, you can have the concept of precedence constraints. And what we're gonna do is we're gonna grab from that green box, we're gonna grab an arrow and map that to our data flow. So in essence, what this is saying is once this successfully completes, then execute this data flow. You can change this to be on success. Oops, sorry. You can change this to be on success or on failure or on completion. There you go. On success, the default is on success. But you could have a flow of your data that maybe doesn't matter if that task succeeds, as long as once it completes, either fails or succeeds, then proceed with the next one. Or you can have the next one run if you have that as skipped, or if it fails, right? So you have control on upon what event this next activity is executed. In this case, we're going to use the default, which is on success. So if you run that, we can click debug. And once you run that, what the first thing it will do is it will start a debug cluster. That's what you see here. I think, I believe in the exercise, it doesn't point to starting the debug cluster manually. But so you could start it manually beforehand, or the first time you run or try to debug a flow, it will automatically instantiate or start that debug cluster. This takes a few minutes, sometimes depending on how busy it is. That debug cluster may take up to 10 minutes. I think the SLA is 5 minutes. Sorry, 10 minutes, something like that. Or there might not be an SLA. But Anyhow, this is just for development purposes. This is just to test out your data flows. So this is not the way it's going to run when you schedule these pipelines. So just be aware that that's going to take a while, and we're going to leave it there, come back to it once it completes. All right, so the next exercise has to do with Power BI. So this is where the fun starts for many of you who have played with Power BI. So we're going to leave this running, and we're going to come back to it. So for the Power BI exercise 3, we're going to go to the develop section. And in this exercise, we're going to do two things. We're going to create a Power BI dataset, and then we're going to create a Power BI report using that dataset that we are going to define. So the first thing we're going to do is we're going to go to our, in the left-hand side, I'm going to leave this open. We're going to go to the left-hand side, and we're going to, we can collapse all this so that you can get a little bit more space here. And we're going to expand the Power BI section. And you can see that in this Power BI section, we have a Power BI dataset full datasets section and the Power BI report section. So we have, if you click on those, you see that there's no Power BI datasets, no, there's no Power BI reports. So what we're going to do is we're going to click on Power BI datasets, and we're going to click on this button here, or option here called New Power BI Dataset. So we're going to click on that. And it's going to walk you through the process to create a Power BI dataset. If you don't have Power BI Desktop installed, you can click on that link and install it. But this VM should already have a Power BI installed. So if you don't see it, I think it's in the actually in the desktop. There it is. It's already there. You don't need to open it right now, but just to let you know that it's there, right? It's installed. Where is my? Here it is. So if you haven't installed it, go ahead and install it. But if you're working off of your laptop, but in this case, that VM that you're using already has Power BI Desktop. So we're gonna start the process. And in this example, we're gonna connect to the Sql Pool 01 table or data cluster or pool, and then we're gonna click continue. And then what it's gonna prompt us to do is to download a Power BI file that will hold the connection string to that Sql Pool 01 cluster. So let's click on download. And once it downloads, click on continue. And we can either open that downloaded file by double clicking on the file, or we can open Power BI Desktop. It should have downloaded to downloads, which is there. So we can double click on that file, or we can open Power BI Desktop, open and specify open file and point to that file. In this case, we're just going to double click on this Power BI file. So it might take a minute to open while Power BI Desktop initializes. So that file that was generated is simply a Power BI file that will hold the connection string to our Sql Pool 01 cluster. And that connection string will allow us to use any tables, any databases and tables that are created there. Okay, as you can see, it's creating that connection because it already created a file with that connection string pre-populated, so we don't have to specify that manually. It already specifies that for us. So it's a great shortcut, great way to connect, right? Now, the next step is it's going to ask us to specify what credentials we want to use with to authenticate to that data set. In this case, we're going to use a Microsoft account, and we're going to sign in using the credentials that were supplied for us in our environment details. So in this case, if you go back to this, you click on environment details, you should see that username that you can paste here. Next. And then the password that's also provided in that tab. Once you're authenticated, it would allow you to connect to the Azure Synapse service. And then it will prompt you with the tables that are available in that SQL pool and specifically that database. In this case, we're going to select the WWI fact sale table. And once we select that and we select that table, it's going to provide us with a preview of the columns and some of the rows available in that table. So what we're going to do next is we're going to click on load. And it's going to prompt us, how do we want to connect to that table? Do we want to import all the rows into Power BI into that Power BI dataset? Essentially, it will extract the data and load it into the Power BI's dataset data structure and data store. Or we can select, in this case, we're going to select direct query. You can click on this link to learn more about direct query. But in essence, direct query, like the name implies, it allows you to query the data, only the data that you require to satisfy a particular visualization at runtime, right? It doesn't preload all the data. It doesn't pre-populate the Power BI cache. It runs a query at the source and brings that data back at report render time, query time. So we're going to select direct query and click OK. And it's going to read the schema. It's going to read some of the rows, right? And if we expand that data set, we can see all the rows that were created for us. We can look at things like, tax amount. We can start playing with this if we wanted. And you can see that it's actually running that at the time we're invoking this. And, we can drag like city key, which should be part of our axis. And we can see the breakdown by city key in all our profit. So we know that this is working. It is connected to our Azure Synapse database, Azure Synapse fact table, in this case, the fact sale table, and it's retrieving the data and it's retrieving it fast, right? It's churning through potentially hundreds of millions of records, and it's returning that data very quick. So we're going to delete this report, this visualization, and we're just going to leave this as an empty file. And what is going to happen is we're going to create a data set out of this file. In order to do that, first we're going to save this file. And we're going to give it a name. You can name it whatever you want, but we're going to just call it our fact sales, right? Or WWI fact sales to be specific. So we're going to save that. That's going to be saved locally on the virtual machine. And then the next step will be to publish that Power BI file to the Power BI service in the Power BI workspace that has been created for us. So we're going to click on publish. And because we are not logged in, as you see here, because we have not specified who we are, right, with our credentials, it's asking us, okay, please authenticate against the Power BI service so that we know to what workspace we're going to deploy this to. So again, you can either specify that here or sign in Power BI desktop, so it knows already your credentials. In this case, I'm just gonna copy my credentials from my lab details, environment details. And it may not prompt me for my password because it may look at my Windows credentials. Well, in this case, it's just picking up the previously defined credential that I have in my web browser. So now the next step is to deploy this data set, right? It's not a report. Well, it is a report, but it has a companion data set. There's no visualization in this report. There's only a connection string and a data set defined. In this case, we're going to specify this Power BI workspace for 06109. Click select. And it's going to publish that to the Power BI service. And there's an extra step that we need to follow, but this essentially succeeds. We can click on that link, but it will take us to the report, and the report will be blank because we know the report has no visualization. What we want to do is we're going to go to the powerbi.com service. We're going to log in using our environment details. And we're going to use our password for that. And that would allow us to connect to our Power BI portal, Power BI service. If you hover or scroll to the, go to the left, you will see that under workspaces, you have my workspace, which is a personal workspace just for you to, for your own purposes, analysis purposes. You cannot share stuff out of your my workspace. It's meant to be personal, like the name implies, right? But if you go to your workspaces, you can see that there's that workspace that has been created for us where we publish that report and dataset. You click on that, we see that there's two artifacts here. There's a WWI fact sales report, which we know is blank. If you click on that, you see that it's a blank report, right? Because we did not add anything into that report. What we were doing in reality is just publishing the corresponding data set, right, that we want to make available. If you click on that data set, it will allow you to create a report from scratch and be able to work with the fields that are in that report. Now, this will give you an error if you try to run this as it is. The reason it's that it will give you an error is because when you publish a data set to the Power BI service, you have to specify what are the credentials that the data set is going to use to read data from the source. Essentially, what is the service account that's going to use to be able to refresh that data in an automated fashion, using an unattended account, meaning that somebody, a person doesn't have to go there, refresh it manually. Upon the schedule you define, it will go and refresh the data. Or if you're running direct query, which is what we're doing here, it knows what is the account that needs to use to do that. So in this case, we're going to go back to workspaces, to the workspace, and instead of clicking on that data set, we're going to click on this hamburger or ellipsis, vertical ellipsis, and we're going to select the settings option here. And you can see right off the bat, right? It's telling us you cannot refresh this data set because you don't have valid credentials. It doesn't copy or use the same credentials you used initially to define this data set. You have to define or store these credentials here because it needs to encrypt them, right? So in this case, we're going to click on Edit Credentials. And we have a couple of methods, a basic method, which is you provide a user and password, or you can save a token, a auth2 token to encrypt these credentials. You can also specify what the privacy level. So if that data set is joining to external data sets, it will give users a warning or an error. In this case, we're just going to do organizational for now, and we're going to sign in. when we sign in, what we need to do is we need to specify our credentials, in this case, our Microsoft Azure Labs credentials. And using those credentials, it's gonna encrypt and generate an OAuth 2 token that it will store as the unattended credentials or credentials used for refreshing the dataset. Now that we've done that, we can actually close here this Power BI. We can close the Power BI desktop. We can save that if we want or not. And we're gonna go back to our Azure portal and finish the steps that we were, the guided steps that we had here. We're gonna click close and refresh. As soon as we close and refresh, or we click on this refresh button, we see that now we have a data set available here called WWA Fact Sales. And if you expand the Power BI reports, you also see that there's a report called, should see a report here. There you go. That report, WWA Fact Sales. All of that, again, is coming from that powerbi.com portal, and specifically from this Power BI workspace where we publish those two artifacts, right? So that shows you that deep integration between Synapse, Azure Synapse Analytics, and Power BI, where users don't have to jump between Power BI or Power BI Desktop. You can specify these data sets and reports right here from Azure Synapse. So, matter of fact, if we delete this report from here, it will be deleted from here, or vice versa. If we delete from here, that will disappear from here, right? So it is synchronizing those artifacts between your Power BI workspace and your Synapse integration. So now that we're here, we can very easily go to our Power BI datasets and hover over our WWI Fact Sales and click on this option for create a new report. So if we hover there, click in that icon, we can see that we now get that same Power BI desktop development experience that we get from our desktop application, as well as the same experience that we get from the portal, right? Same exact experience, right? And we can collapse this if we want a little bit more real estate. And from here, it's pretty much the same way, right, of developing reports. We can choose, in this case, a bar with a bar chart with a column chart with a trend line. Then we can specify for our shared axis the salesperson key. You can expand this a little bit. So the salesperson key as our shared axis. Then we're gonna choose the total excluding tax as our column values. And then our profit as part of our line values. So now you can see that those totals with the profit as our line values. And then, of course, you can do all the filtering and all the data manipulation here. And we can say, for example, under the filter, so if this is hidden, you can expand the filter section. So make sure that you have the that chart selected. If not, those filters will go away. So select the chart. And then you will see under filters that profit field. And we can change this to filter profit where my profit value is greater than, and in this case, I believe it's 50 million. 1, 2, 3, 4, 5. What does the example, what example wants us to do? And then we click on apply filter. So now you can see that our data was filtered and it's only showing data for where our profit is greater than 50 million. And you can see that if you follow that trend line, you can see that all along. And once you are done, then you can just save this. So you can click on File, Save As. And let's click this profit by I think they wanted to call us, doesn't matter, but profit by so now we can close this. And if we go back to our develop section again, you can see now that under Power BI reports, if we refresh in case it doesn't show, now we should see that profit by salesperson. And we are able now to visualize and consume that data. And depending on the role, if you're a contributor, you can actually modify this and customize it to your needs, right? If you're just a reader or a read-only person, then the only thing you can do is you will not have access to modify this. You're only going to have access to consume the report. But again, this shows you in end-to-end, right, from exploring and discovering data using a SQL notebook or a SQL query, SQL scripts, or using notebooks with your preferred language, Python, Spark, Scala, or C#. Then doing some integration, some manipulation of data with your data pipelines, all the way to authoring and developing datasets, Power BI datasets and reports within the same user experience, right? You don't have to go to another service, to another resource in Azure to be able to do an end-to-end analysis from exploring data, ingesting data, transforming data, to defining datasets and reports within the Azure Synapse Studio. The last exercise, which we're not going two exercises. One is around performance. You can test that out at your leisure, but the other one is around data science. And this data science lab seems to have some issues. It seems like there's some issues with the way the model was generated. But this gives you an idea in a workflow, right, of how you need to prepare your model to be able to use it. And essentially, it follows this workflow in which you create a model, either in Azure ML or in your favorite modeling software. Once then you train that model, you convert that to an ONNX, I guess it's pronounced, format. You export that to a database table. So essentially your model is converted to a binary, into a binary format, into a table column. And then you refer to, or you register those models in your SQL pool, load that in from that table, and then execute a predict function within your SQL script. And here it shows how you import that, how you convert it into an Onyx format, and then what is the function that you use to run that model against your data. So in this case, they declare, they select that model that's stored in that table into a model variable. Then they run this prediction function, select the results in the data that you're passing, in this case represented by the D alias. So this is the data that you are passing to the model. This is and then here is the result, the prediction result, which is a column called prediction. It's a data type real, meaning it's like a decimal number, right? With many decimal places. That is alias as a P, right? So here it's returning your original data set along with your predicted value. And it is selecting this from a function called predict, specifying what is the model they're going to use. In this case, it's a model that has been stored in this table that has a binary. It's stored as a binary model. So you define that model. You define what is the data that you're going to pass to that model, and what is the prediction that you're going to get back. When you execute this function, you will get something like this, where you're going to get the data back along with the predicted value. In this case, what I believe this is the amount, how many items of a particular stock item or a particular product a customer will buy, right? And you simply you get back what is that predicted count of products. And that pretty much finalizes our labs. I know we had this data flow that we were debugging, and let's see, make sure that it ran. For some reason, this didn't run. Okay, but essentially, now that our debug session has started, we can now just debug that. And we would see, let me see if this ran or not. I'm gonna refresh, and I'm gonna see this tables, see if that could run or not. Apparently it didn't. That's fine. Yeah. So the idea here is, you would create put the presence constraints as necessary. And then debug it to run this data flow interactively, or you can create a trigger that will allow you to define a schedule. And as you can see here, this could be on a regular schedule, meaning it will run exactly at this time, every 1 day, every 1 hour, every 1 minute, month, week, etc. Or you can have a tumbling window, which is essentially it will run 50 minutes, but if the previous execution has not completed, it will wait until the next, and it's like a tumbling window, right? In that area. There's also storage events that allows you to execute a pipeline upon arrival of a file in a particular container, right? So if you're expecting data to arrive in a blob storage location or blob storage container, you want to process that file as soon as it arrives. It has a trigger specifically for that. And then you can also now, which is still in preview, use custom events that are based on a topic that you have defined in Azure Event Grid. So this is a very, very cool capabilities that they're continuously adding into Azure Synapse to be able to run or execute pipelines based on storage events or based on event grid events, right? So this is great if you have some type of API-based or brokering-based architecture where you want things to execute, to run, depending on certain events, certain topics, conversations happening between different applications or within different systems. All right, so with that, we're going to conclude today's workshop. I appreciate for staying with us today. Feel free to ask any questions in the Q&A, or feel free to send me an email. If Madison, if you want to put there my email address, I will be happy to answer any question that you may have. And hopefully this was useful for you. If you have any specific questions, Madison is also going to send out my contact information along with a link to schedule a 30-minute conversation with me. Anything, right? If you want to know how you can learn more about Azure Synapse, if you want to know what are the next steps that you want to follow to implement Azure Synapse in your organization. If you're interested in learning perhaps what are the services that we provide, maybe areas where we can help you, those 30 minutes are essentially take it as free consulting, right? And then if there's an opportunity for us to help you, we will be very happy to help you with architecture, strategy, planning, or even implementation, right? Which is what you might be after, right? Implementing this the right way the first time and not have to spend cycles and implement this the right way. So if that's said, if there's no other questions, unless yeah, I don't see any other questions. Thank you again for joining, and feel free to reach out to schedule time with me. And I hope to see you in some other event pretty soon. So thank you very much. Have a great rest of your day.